Hi, I'm James Montemagno, Developer Evangelist at Xamarin. And today we're going to take a look at the Xamarin platform, enabling you to leverage your C# and .NET skills to build out beautiful native iOS, Android, and Windows apps inside of Visual Studio with Xamarin. So what does it mean to be a native application? That's a good question. I get asked that a lot. Well, over my years of doing cross-platform mobile development, I boiled it down into three important parts that your apps need to hit to be real fully native apps. And first is that all these platforms look and feel different because they are different. We want to craft a great native user interface. There's a reason that someone bought an Android, an iOS, or a Windows device. They like the hardware in their hands, but they also like the look and feel of the software. So our apps should adhere to those guidelines, and they should just look like a native application running on the platform. Now, as developers, though, we like to tinker, and we like the latest and greatest APIs. And if there's something that we can do in an SDK or on a platform, we want to do it. So we want to have access to every single native API. So if I want to integrate with AirPlay or Bluetooth or beacons, I should have access to add those great native features to my application to make it stand out in the store. And of course, those applications just need to perform. Your users are going to download them, play around with them, they click a button, it should just work as expected to have real great native performance. So how do you get there? How do we build and architect these mobile applications to really hit all 3 points? Well, you could go with a traditional kind of silo approach here, which essentially is building 3 applications 3 times, 3 different languages, 3 different IDEs, multiple teams. So you're using Objective-C or Swift and Xcode to build a native iOS app, Java with Android Studio, or Eclipse if you have to, and then of course C# for your Windows applications inside of Visual Studio. And while this does give you a great native application, it doesn't necessarily lend any code sharing. And of course, like I said, you have multiple teams, different dev environments, different CI. It becomes really tedious, really fast, and really expensive. How do you sim ship features or fix bugs across all your products? So then you may think, well, James, why don't you just build and code everything once and then you get some apps? Why don't we just write everything once? And there's several approaches out there, but often this kind of adheres to kind of taking all this CSS and HTML and just shoving it in this bucket and apps plop out at the end of the day. And the problem here is that often, not always, they're kind of just running in a web browser and you're not getting that full native performance. So you kind of get a lackluster user experience. And of course, you're kind of developing against their API, not the API of the platform, so kind of a subset. And like I said, as developers, we want access to everything. And that's really where Xamarin shines. We enable you to build a shared C# logic backend for all of your mobile applications. Essentially, anything that's the same, your models, view models, RESTful service calls, SQL databases, things that are the same inside of your apps. Then we give you the tools to build and access the native APIs and build a great native user interface for iOS and Android right inside of Visual Studio. Now, how this works if you're a Windows developer, essentially you have a bunch of .NET libraries running on the .NET runtime on some Windows platform. Things like Link, IO, XML, this is obviously just a subset, but it's amazing things like a .doit, and there's some API available to me. Now, when you want to go to a specific platform, maybe it's Windows 10, maybe it's ASP.NET, you download an SDK and you get some great namespaces and some new APIs available to you. So storage, networking, foundation, things that are specific to that platform or to that hardware. Maybe you are accessing geolocation on a Windows 10 mobile device. You can think of it exactly the same when you want to go to iOS or Android using Xamarin. You get all that .NET goodness on the bottom, all available to you to be shared across your platforms. But instead of running on the .NET runtime, you're running on the Mono runtime, the original open source implementation of .NET. And then we create C# wrappers around every single API in iOS and Android. So what that means is if you want iBeacons, core graphics, core motions, those are all available in C#, and we add great C# features too, like link, lambda, async await, events, delegates, things that we know and love as .NET C# developers. So even though we're accessing that native API, we're doing it in C# with all those great features that we've kind of known to love. Now, of course, we do the same thing on Android, but of course, we have the Android namespaces available to us. Now, when it comes to native performance, it's really important to kind of know exactly how everything's working. And what we do on iOS is a full ahead of time compilation. Take your C# code, compile it down into IL, compile it one more time into LLVM bytecode. Run that right through an LLVM compiler and optimizer, and boom, native ARM binary running natively on your iOS device. And you have all your .NET goodness in there, all of your C#, everything's compiled, all those great bindings and everything to create a great native app. Now on Android, we can leverage just-in-time compilation to run the mono runtime side-by-side Android's Art or Dalvik runtime. And what this means to your users is they're getting a great native experience, and there's no additional install, no anything special. They go to the App Store, they download it, and they have a great app on their phone or tablet, or anywhere else that these devices are going to, these OSs are going to. And of course, we have great Visual Studio integration. Great iOS and Android designers to build out beautiful native user interfaces. And as these OSs evolve, so does Xamarin. We've had same-day support for iOS since iOS 5, including the latest versions of iOS 9. Of course, it's not just about phones and tablets anymore. It's about where else can I take my .NET and C# code? We want to take it everywhere. So whether you want to target Android Wear, Apple Watch, or any of the TV OSs, you can take your C# and .NET code and bring it there. So truly anything that you can do in Objective-C, Swift, or Java, you can do it with C# inside of Visual Studio with Xamarin. It's never been easier to get off the ground running. So when you want to start, just go and when you're installing Visual Studio, just select Custom Install. Then on the next screen, select Xamarin, and every single tool that you need to get started with cross-platform native mobile development will be installed. Now, if you already have Visual Studio installed, don't worry. Just head to xamarin.com/download for our universal installer that'll take care of everything. Now, before we jump into some code, let me show you what you'll be seeing, and let's talk about code sharing. Because not only are you crafting these great user interfaces, but you're sharing a vast amount of code in your business logic. And we do that by leveraging portable class libraries. They're just like class libraries that you've probably used forever, but they're portable, which means that you can target multiple platforms from a single assembly. When you create a portable class library, you just check what platforms you want to target, including iOS and Android, and you get a subset of the .NET libraries that are available on all of those platforms. Then you can mix and match and pull in more libraries right from NuGet, and pull in everything that you need from JSON.NET, HTTP, Azure, anything that you need to start building out your backend for your mobile applications. And of course, you can ship your own NuGets too. Now, of course, this all leads to great code sharing statistics. And on average, developers using Xamarin share 60 to 70% of code across all of their platforms. And here are a few examples. My favorite, iCircuit, from my very good friend Frank Kruger here up in Seattle. This application is a circuit simulator and is sharing anywhere between 70 all the way to 90% of code across the different platforms. And that's what you're seeing in blue. And then any of that gray is the platform-specific tweaks to the user interface or platform-specific APIs that you have access to. So let's go ahead and just take a look. Here I am inside of Visual Studio 2015. Now once you have Xamarin installed, to get started, just create a new project. Normally you'll see all of your Windows or web applications, but when you have Xamarin installed, you'll see a bunch of Android and iOS and cross-platform project templates. Here's Android to create a blank application or an Android Wear, Apple Watch, or iPhone or iPad specific applications. Now, when you want to set up your project for a full cross-platform, we have great blank app templates for you. Under Blank App Native Portable and Native Shared, this is building out platform-specific user interfaces with that shared code backend. So I've gone ahead and created a project using the native portable, creating a portable class library that will be shared across iOS, Android, and Windows. And this is where you'll want to get started. Now, the application we're going to build is going to use a nice API that we can search for maybe a restaurant, or in this case, coffee, to find it based off a location. And it'll return the closest coffee location to me. So let me go ahead and open that solution. So this application is called Coffee Finder. Let's take a look at the project structure. Here we have everything in one solution, a portable class library with all of our models and view models, Then all of our Vue-specific code will be in our Android, iOS, and our Windows applications. Now, we don't cross-compile at all, so when you want to actually access those native APIs for Android or iOS, you write it in the project. They have their own compiler and optimizer to create great native experiences. So let's start with the Android application. We can see here that I have some drawables and layouts available to me. And then down here, we have our main activity. And this will be the entry point for our application. But let's talk about our shared code, because that's where we really want to take a look at. So to get started, what I've done is I've created some models, such as location with a name, a latitude and longitude, and what a place is. And what we can see in this code is that we have our address, geometry, and icon. I'm hitting a RESTful endpoint, and this is returning everything to me as JSON. And I'm going to use our good friend JSON.NET, the library, to pull down and deserialize that into these objects. Now, all of these models are here, but let's go ahead and take a look at the real winner, the main Vue model, which can be found under our Vue Models folder. Here I'm going to hit a RESTful endpoint. There's a Google API available to me. And I'll have some properties that I can access in my platform code. So here's my message, how many places I have, and the closest place near me. And when I want to access and actually call into my shared code, I'll create my main Vue model, and I'll call into getPlacesAsync, which is an async task that will return a list of places to me. This takes in a few properties, such as the query string, and if I want to use the location or not. Now, we're going to start with just the query string, so I can pass in coffee, hamburger, hot dog, Thai food, anything like that. So what I'll do is I'll go ahead and I'll create my query. And this API requires a specific location. So I'm going to search for Seattle, Washington, USA. This will build up my API key. I'm going to use HTTP client to go ahead and grab that string, that JSON string, all asynchronously on a background task. I'll use JSON.NET to deserialize it. And then I'll go ahead and say, hey, do I have any places? And if I don't, I'll say nothing is open. I'll also go ahead and format a string using some brand new C#6 features and say, we found this location for the specific query that you gave me. And if anything goes wrong, I'll say, hey, something went wrong. And that's a part of my shared project code. So when I want to bring it into Android, we'll take a look at the references. And down here, we can see that I have the Coffee Finder portable class library, JSON.NET, a bunch of plugins that we'll talk about in a little bit to actually access platform-specific code, and of course a few support libraries for Android. Now to start building out our user interface, we'll want to take a look at our main Android XML. And here's our Visual Studio Designer for Android built right in. And we can see I have a full toolbox available to me over here with every single Android widget. So let's say I want to add a text, a label. We'll go ahead and slap that down and put it over there. So now we have a edit text, a button, and the label that we can update. Now, Android views are built with XML. So here I'll switch to the source tab, and we see I have a linear layout with some padding and some identifiers that I can access from the code behind. And I can go ahead and update the text here. And I'll say, go ahead and enter something. Flip back to my designer. My designer automatically updates with everything that I commented back and forth. Or I can come down into my properties grid and browse all of the properties available on any of those widgets and set them right here like you would expect. So let's tie up our code behind. Every page in Android XML has some code behind associated with it. So that happens to be my main activity that I mentioned earlier. Here I go ahead and specify my layout resource, and on create is when this is started up. In Android, you have to go ahead and find each element on the screen based on their IDs. So we have that button, edit text, and the text view, the label, if you will. Whenever I click that button, I just have an async Lambda expression to say, hey, go out, find those places async, and then go ahead and update the label. That's it. Everything will be taken care of for me automatically. I could even disable the button by setting the disable property to false, and when I come back, setting it to true. And that's it. That's my code behind, because the bulk of my logic is all in shared code. Now, you'll want to go ahead and set that project as the startup. And then, from your debug menu, you'll see any Android emulators that you may have, or a physical device that's plugged in. So let's go ahead and add a breakpoint here. There we go. I'm just going to go ahead and start debugging right on my Nexus 6. All right, we've entered debug mode, and I have a little screen mirroring application, and here we go. I can say coffee, for instance. I'll say find stuff. And when I select that button, we're going to go ahead and hit our very first breakpoint. There we go. We can investigate the click button, the native Android widget. We can take a look at our view model and our query text, coffee. We'll go ahead and let it go. This will call off to the internet and then come back down with our coffee. Here's our message. And continue to debug through, and we can see that our label has been updated that we found Stumptown Coffee in Seattle, Washington. There we go. And it's automatically updated the user interface. All of that logic was in our shared code project that we can now bring over to iOS and Windows. So let's take a look at how we would do that. Now, in our iOS application, we have a very similar flow. We have resources such as images and icons, and then we have something called the main storyboard. And this is going to be an entire outline for our application. So we have a navigation controller, so I get a nice title bar on top. And again, we have a toolbar with every single widget that I need over here on iOS. So if I needed, I don't know, a switch, for instance, I could go ahead and drag that switch down. Then I could go ahead and access all of the properties in the property grid or any of the events. Now we don't need a switch, so let's go ahead and delete that. But let's go ahead and maybe make this text property a little bit bigger. So we'll come down and we'll just pump up the font size. There we go. Now in this instance, we have a text field and a button. And of course our label. So let's go ahead and give these names, such as button find or text field find. There we go. Now when I double click on this button, it'll automatically take me and create the click handler for me in the code behind. And this is the UI view controller, or similar to the activity in Android. I've created my main view model from my shared code, and now we can just go ahead and write that same little bit of logic. View model.get places async. We'll say text field find.text. And then we'll say label location .text equals view model .message. There we go. It's only 2 lines of code that we have on our code behind, and the rest is handled in the shared logic. So let's go ahead and set the iOS project as my startup. And we'll see I'm connected here on my Mac. And in fact, I'm actually inside of VMware running on a Mac today. And I have an iOS simulator. We can see from the drop-down menu that I have all of the different iOS simulators available to me. And I can just go ahead and start running the application. Here we go. We have coffee. I can say find. And it'll go out and it'll use the same exact shared code to find the same location in Seattle, Washington of Stumptown Coffee. Now, last but not least, let's go ahead and take a look at a Windows 10 application. I've brought in the same exact libraries like I did in Android and iOS, my shared code, and some NuGet packages such as JSON.NET. I've created a very simple user interface. We can go ahead and make this just a little bit bigger. There we go. And what I'm doing here is simply just going ahead and saying coffee, find, and then I have a text block down here to display the results. So very straightforward. And in my code behind, whenever I click that button, again, the same just little bit of code to call off into our shared PCL. So let's set the Windows project as our startup, and we'll just go ahead and run this locally on the machine. There we go. We'll find coffee, and we found Stumptown Coffee right in Seattle, Washington. So there we go. We just started building our very first application right inside of Visual Studio for iOS, Android, and Windows. But what happens when you actually want to get into the platform-specific code? And when we look at our shared C# business logic, we often have these little boxes up top, the purple, the green, and the blue. But what is that? What does it mean? Because we've only been writing this shared C# backend logic. Well, that's any of our UI or APIs specific to the platform, things like battery, GPS, lights, notifications, text-to-speech, or anything else that are on these different devices. Now, some APIs are specific only to one platform, but many of them, like you're seeing here, are available on all platforms, but with a different API. Now, we thought that kind of stinks. And there should be a better way to access these native APIs from shared code. And we said, hey, what if you, as a developer, didn't have to write all of this code, didn't have to learn the iOS or Android specific APIs? And what if you could access, GPS, for instance, from your shared code? That would be a much more enjoyable development experience. So let's say, for example, you want to use text-to-speech. Well, the API that you would love to have is speak, and you pass it a string of hello world. Then under the hood, it should call AV speech synthesizer, text-to-speech, or speech synthesizer on Windows. That's what we want. And that's why we created plugins for Xamarin and Windows, giving you a common API for all those underlying APIs of the platform, such as taking photos, settings, push notifications, or GPS. You can find out all about the plugins for Xamarin and Windows at xamarin.com/plugins, and take a look at all the source code, because they're all open source, and even learn how to create your very own. So let's go ahead and extend our application we started building, and let's use a plugin. All right, we're back here right inside of Visual Studio in our Coffee Finder application. But let's really spruce this up and start adding some native features and, of course, use a plugin. So we want to go ahead and actually start using geolocation. So the first thing that I'll do is I'll go ahead and take a look at my NuGet packages. And we can see what I have installed and found was the plugin for the geolocator. And I've installed it into all of my applications. We can even see the cross-platform API of locator.getPositionAsync. Pretty straightforward. So let's go back into our shared code, our main view model. And here we were passing a parameter called withLocation. So what I can do here is I'll say if withLocation, else, and we'll go ahead and use the different API to pass in the latitude and longitude. So the first thing I want to do is say var position equals await cross geolocator.current.getPositionAsync. And we'll give it a timeout of maybe 10 seconds. There we go. Now we have my position. Then what we can do is go ahead and generate the request URI and say equals string.format. And instead of passing in the search query URL, we're going to pass in a search location URL, which will take in the query, the position dot latitude, and we'll toString this, and we'll do a culture info dot invariant. We'll pass it the position longitude dot toString, culture info dot invariant culture. And last but not least, we'll pass it the API key. There we go. So that's the URL that we're going to go ahead and hit. Now, we need to go ahead and update our iOS application to actually call this location. But also, let's go ahead and maybe add a map and put a pin on wherever location we find, since we'll have the geolocation. And we can see that we'll also update it with a little bit more information of how far away it is. So let's go ahead back to our main storyboard for our iOS application, and let's add a map. Go ahead and drag this map down. Let's go ahead and fill the rest of the screen here. There we go. And now what I'm going to do is I'm going to go ahead and name this main map. There we go. Now immediately that main map will be available in my code behind. So main map dot. And I can go ahead and access that native map that's part of MapKit. So of course we're just passing in the text here of coffee, but we'll also want to say true. So we're going to use the geolocation. Now I have a little bit of code, just 4 lines of code to put the pin on the map. So let's go ahead and bring that in and walk through it. The first thing that I'm going to do is go ahead and say, let me create a core location coordinate 2D, so latitude and longitude. And from our view model, I'll pass it the latitude and longitude of the closest place. Then I'll go ahead and add the annotation, which will give us a nice little pin. And then I'm going to go ahead and zoom the map to a specific region, about 2 miles or so above in a grid. There we have it. That's 4 lines of code to add a pin and also zoom in the camera directly to a region. Now, we can go ahead and start deploying this right to our iPhone simulator. Here we go, Coffee Finder has restarted. Now, I'm in a simulator, so the actual location will probably be somewhere in Cupertino, because that's where Apple has it set by default. So I'm going to go ahead and say Find Location. And here we go. We can say we found Pete's Coffee. That's 0.74 miles away. But let's add some breakpoints so we can really see what's going on. I'm going to head back into the main view model. And up top, let's go ahead and set a few breakpoints for the location. And then let's go ahead and take a look at our query results. So I'll come back and I'll say find again. And we've hit our first breakpoint and we're getting ready to call that shared code to find our location. Go ahead and continue on, and it's boom, just that fast. And we can see that we have latitude, longitude, and speed or heading or accuracy that we're going, and a specific timestamp. Now we'll go ahead and use that latitude and longitude to build up our query string and go off and grab it. So there's our query string, and then here's our result, this big chunk of JSON that's been returned to us. Then we'll go ahead and deserialize it. And now we have all of our places right here, 20 places to be exact, that are around us for coffee. So no matter where I'm at, based on my current geolocation, I can find coffee for me. And there we go. I can go ahead and tap the pin, Pete's Coffee, right there. I could use another plugin called External Maps to launch and start navigating right away. It's just that simple to start accessing these native features across iOS, Android, and Windows because plugins work everywhere. So we just kind of looked at how to build a cross-platform native iOS, Android, and Windows app inside of Visual Studio. But what about something full-fledged that you can get your hands on? Well, that's where the My Driving application comes in. It's an IoT mobile app sample to get you off the ground running with a beautiful cross-platform native app. Let me go ahead and pull that solution up. The first thing that you'll notice is the beautiful storyboard, a full iOS storyboard to take a look at to build out lists of data, maps, profile pages, settings. Here we can see that we're going to be doing some mapping using our geolocator plugin that we just used, but also doing profiles for, let's say, Scott Gu and how good of a driver he is. Now, this application has tons and tons of shared code. Not only are we sharing our entire backend, all of our data stores using Azure mobile apps with an online-offline synchronization, we're also using libraries to pull and read OBD sensor data, and of course our full portable class library with all of our models and all of our view models for every single page. Then we have platform-specific user interfaces for iOS, Android, and Windows 10. So this is really going to give you everything that you need with great architecture and how to get started building these applications. So for instance, maybe you want to start recording a trip, and here's our current trip view model. We say I want to start tracking this trip. I use our geolocator that we just used previously, but instead of getting a specific point, we're going to start listening for geolocation changes. And we're just going to register an event for the geolocator. Then down here, whenever anything changes, we'll go ahead and calculate some distances, set up a trip point, and even read data from the OBD sensors on our vehicle. Then we'll go ahead and send that trip point up to IoT Hub. And to do that, it's actually as easy as just a few lines of code. We deserialize our blob, and then add trip and send it to the IoT hub. That's it. Package up our JSON blob and we're done. And finally, what we're going to do down here is update what we need to display in the user interface, our elapsed time, fuel consumption, and how far we went, and tell our user interface to update. That's it. Let's take a look at the application. I'm going to pull it up here on Android, Windows 10, and iOS. Here we're actually tracking along, and I'll go ahead and start recording a trip. If I was on a real device, I could go ahead and perhaps tie it up to my OBD sensor, but we'll use some simulated data. And we can see as I'm traveling, my miles are updating, duration, engine load, and gallons that I'm using. We'll go ahead and stop these recordings and we'll name this trip here. And we get a full detailed summary. Now at the same time, not only did we save and display trip summary information, but we also save that trip up into Azure. So we'll go ahead and refresh the list data here. We'll see what it looks like in our past trips. Here we go. Just a few seconds ago were these trips recorded and brought right into all of our different devices. I could go and tap on a trip and start playing back the details. I could also go into my profile and see how good I am as a driver. 81, not bad. Pretty good, and I've gone quite a far distance. And there you have it. We started taking a look at how to build out these great native applications on iOS, Android, and Windows in C# and Visual Studio with Xamarin. But now you have everything that you need to get started. Go download the My Driving source code and start playing around and start building these great cross-platform mobile apps today. So there you have it. We just took a look at how to build our first beautiful cross-platform native iOS, Android, and Windows apps, all in Visual Studio. We extended them with plugins, and then we took a look at My Driving, which you saw here at Build, which is a beautiful, stunning application taking advantage of great hardware features and pushing everything up to IoT Hub. You can get started today at Xamarin.com and learn about everything that Xamarin has to offer. And of course, you can download all the source code that you saw here on my GitHub. And of course, follow me on Twitter at James Montemagno. And thank you so much.